to Dig and Dive with David, where curiosity is learning. Thank you for joining today. If you like the show, please share and subscribe so you never miss an episode. And now presenting your host, David Dan Singh.
Hello, folks. Happy Labor Day for the people here in Canada and in the US. I'm very excited about today's episode, where we have a lot to discuss and share with you about fossils and dinosaurs. So if you're the dinosaur enthusiast like me and you don't want to miss this episode, and please make sure to share this with your friends and family. Alena Iskanderova is a scientist paleontologist who focuses on integrating IT technologies for discoveries of fossils located in the United States and around the world. She also has a startup campaign called the Museum Traveler, where she travels with her team to museums around the world and share about natural history, wildlife, and science. Alena, I'm so honored to have you on the show, and thank you for accepting the invite, and congratulations once again for your startup.
Hi, David. Thank you. Thank you for inviting me.
You're very welcome. Let's start from your beginnings. Where you're from, your education, and how you got into paleontology. When did your interest first develop in paleontology?
So my background is in computer science and engineering. I got my degree in Russia, so I was born there. My dad is Bashkirian, my mom is Russian, so I'm mixed of two races, two ethnic groups. I got my interest probably when I turned 4 or 5 years old. I remember we had so many encyclopedias at home, and I was just browsing. I was looking for Paleozoic. I think there was a couple of pictures of trilobites, and I just got hooked. Like, what are these creatures? And I started digging around the house, in the backyard, like everywhere. I was bringing home some half-decayed animals, and my parents were just like embarrassed. Oh my gosh, what is that?
Sounds very interesting. Did you have any? When did your interest first develop in paleontology? Was it the early years when you were at home as a kid, or?
Yeah, so I was learning and studying paleontology as a self-education since I turned 5. So I was reading, I was going to the library, I was taking courses. But my parents highly advised me to pursue my career in computer science. And probably it was the right decision for me at that time. So that's it.
Yeah. Did you have any professionals or family members who served as role models when you were younger? Do you still have any now?
Oh, yeah, absolutely. My parents. My dad is physicist. So he has tons of patents and inventions in physics, nuclear physics, quantum physics, microelectronics. So yeah, I was totally exposed to discoveries and science debates. My mom, she's a brilliant computer science developer. And when she was in her 20s and 30s, she was an avid traveler. She was traveling around everywhere.
Wow, that sounds very interesting. Was there anything you did or learned as you were on your way to your current career that you feel got to you where you are today? By this, I mean any sort of field experience, maybe a networking class or something like that.
So I have quite an interesting, unusual story how I entered the field of paleontology.
Because you graduated in computer science, right?
Yeah, and I was working, so I finished my career in IT as a project manager. Quite different. So it's like nothing in comparison to paleontology. During the COVID, I started my paleontology blog on Instagram, and it became pretty popular. I started talking to different people, and they got interested in my science communication skills. So I decided okay, so maybe this is the right time to switch my career because this is what I'm interested in, really.
Yeah. So do you think that when you got into paleontology, do you think this is going to be like a full-time career for you?
So right now it is a full-time career for me. Yes, it was probably half a year of transition, but yes, right now it's a full-time.
That's very good to hear. I'd like to know, and for the people and for our audience, what is your favorite book of all time?
I knew you would ask that. I'm a huge book nerd, so I brought a couple books. Probably one of my favorite is Richard Forty, The Trilobite.
Mm-hmm.
So this is one of the best book about the evolution, about how life evolved, and like this one is The Rise and Fall of the Dinosaurs by Steve Brisati. He's one of my favorite authors, honestly.
Yes.
The best science communicator. He can write textbooks. I have also the Dinosaur Paleobiology by him. It's a technical book with a lot of anatomical details, but you can like read it in any age and like any levels. So it's quite understandable. He can bring science to everybody in the best way.
Yeah, for sure. No, The Rise and the Fall of Dinosaurs, I'm reading that too. I don't have a physical book, but I'm listening to that on audiobooks. It is a great read, for sure. And I only got hooked into that when you, I think you posted about this on your Instagram. And I was like, this is something I have to get my hands into to understand about the rise and fall of dinosaurs. Interesting. It not only talks about dinosaurs, it talks about, other prehistoric creatures and all that stuff. Love it. So you're a scientist. Could you walk us through your day at work?
All my days are different. So as you're following me on Instagram, you probably know that I travel a lot. I do photogrammetry. So this is converting fossils, track sites into 3D models. So usually I start my day pretty early, like 7 a.m. I go to the site. I do a bunch of photos, depending on the size, of course. Then after like 5 p.m., I'm going back and I'm processing all the photos in the software on my laptop. So something like that.
Sounds like a very long day. Do you often visit sites, or is it mostly outside, or do you also have some admin work in the office?
So it's half and half. So I try to do as much photogrammetry as possible.
Yeah.
Unfortunately, it's like really scientifically heartbreaking. I have to admit that a lot of fossils, when they're left in the field, like tracks, for example, they are eroding pretty fast.
Oh, wow.
Of course, depending on the lithology, but for example, the sandstone is affected the most. And like within 10 years, you can just lose all the depths and you can lose all the tracks.
Yeah, for sure. Yeah, I didn't know that it is eroding really fast.
Very.
Yeah. And do you do a lot of field research and fossil findings? Do you have a particular interest in this branch prior to starting your career in photogrammetry, right? How did you choose it?
I was always interested in computer science, which is explainable, right? Like 10 years in IT.
Pretty sure, yeah.
Yeah, so it was a smooth transition to bring some IT technologies and my expertise and experience into paleontology. I met my teacher, Nefra Matthews, so she's probably one of the most brilliant photogrammetrists in the United States. I admire her work. I was very lucky to met her last year, and she enrolled me into USGS photogrammetry class with all the great people who are doing aerial, like drone photogrammetry and close range photogrammetry with a camera, which is I'm specializing in. So probably, yeah, she is the most influential person in my life in paleontology right now.
Yeah, it's always interesting to have people like that in your life. They're very motivating and they're always very inspirational. And you can get a lot of help from them, especially your mentors. Do you consider her as a mentor?
I think I have a couple mentors. So Nefra Matthews is definitely my photogrammetry mother. She was raising a baby photogrammetrist for 2 years almost. Dr. Paul Murphy is another mentor. So he taught me all the geology and stratigraphy and sedimentary, like everything. All my knowledge came from all the field experience we had together, starting from Oh, it's been, by the way, almost 1 year.
Wow, that's quite a time there.
Yeah.
Let's jump into some of the basics here, and I wanted to know your opinion on this, coming from the expert, obviously. So, could you tell me? Could you give us an idea of some of the basics of what mammals are? What is a mammal, and which anatomical characters define them?
Oh, that's a tricky question. I'm not really specialized in mammals, but I will try. So obviously, those are glands that produce milk. Also, there is 3 ears, internal ears. I believe we have neocortex. This is the department of the brain which allowed us to develop language and this cool 3-dimensional vision that we can just transform 2D to 3D in our mind, special thinking. Also, this is hair or fur, which is also obvious, right?
Yeah, that's exactly what I was thinking. About mammals. Mammals. Yeah, go ahead.
Which is really fascinating, at least to me. Mammals did evolve pretty much at the same time as the archosaurs. So it was in the Triassic
period.
Yeah, in the Triassic period.
Yeah. On one of your posts, you mentioned about one of the most important events in the history of Paleozoic era, called the Cambrian Explosion. And I've read that so many times. Could you, for the audience, tell me about that?
So the Cambrian Explosion happened 540 million years ago. Why it is so important? Because almost all the families we know today, like insects, crustaceans, so basically predators, by the way, all those groups of animals evolved during this time. And why it's an explosion? Because it happened pretty fast. So from the geological perspective, it's about like 10 to 25 million years.
Yeah.
So within this very short time, all the major groups of families evolved.
Yeah, for sure. Are we talking about before the dinosaurs, or are we talking post-dinosaurs?
Oh, it was way before.
Way
dinosaurs.
before. Okay, for sure.
Way before dinosaurs.
And can you give us an example of what type of insects or what type of creatures, prehistoric animals, existed during those times?
Oh, yeah, absolutely. For example, worms and other animals, invertebrates with the exoskeleton evolved during this time. We think that probably the push was an increase in the oxygen level. So the level of oxygen during the Cambrian time was pretty much at the same percentage as today.
Okay.
And probably it gave a huge push to some. So the presence of oxygen pushes the process of metabolizing food. So it releases much more energy. We think that probably it gave an opportunity to develop such like energy hungry innovations as muscles or exoskeletons or shells or teeth. The first predator evolved during this time. For example, Anomalocaris was one of the apex predators. It had complex visions, a pretty developed brain. So I'm wondering if it went extinct. So what will be today?
Yeah, this is a very historic, important event that occurred. I didn't know about the oxygen. You mentioned about the oxygen level as compared to today. And was that a good thing for the mammals at that time, or was it not a good thing?
Oh, there were no mammals by that time.
Oh,
so 540 million years ago, it was almost ocean everywhere, and the most dominant life was trilobites. So mammals evolved 200 million years later.
Yeah, yeah. Okay. Besides paleontology, I'm just curious, what other sciences did you study?
Well, I always love to challenge my brain, so I'm taking classes. Sometimes it's like super random. I took a cosmology class in California Technology. I did the game theory from Stanford. I'm doing sometimes like MBA classes. So I really love to challenge myself.
Wow, that's interesting. And obviously, you graduated from computer science, and you did computer science as well. That is also considered as science,
Well,
maybe. Now, how do you determine, Alena, where you should find for fossils? How can you tell the difference between a rock and bone? And how do you determine the species?
oh, okay. So let's start with where to look for fossils. So are you interested particularly in the dinosaurs or any fossils?
Anything. It could be any fossil.
Any fossils. So if we are looking, for example, to trilobites, so we have to look at the stratigraphy map. So all the rocks, they are three types of the rocks, like metamorphic, sedimentary, igneous. And of course, we have to look at the sedimentary rocks of the particular age.
Mm-hmm.
We can use the Google Earth or some maps to probably mark the most potential sites. We can look at the outcrops. So those are like number one where to look for fossils. But of course, if you're an amateur, you have to understand that not all places are allowed even to trespass or, of course, collect fossils. In the United States, in most states, you can collect vertebrate fossils, including tracks.
Is that the same?
Worry the most.
Yeah. Is that the same case for dinosaurs, dinosaur fossils?
Yes, so dinosaurs, they are vertebrate fossils. So body fossils are prohibited. You can collect only under permit. And you can get a permit through the institution or your affiliation with the university or the museum. So all the fossils you are collecting should be stored somewhere.
How do you identify what species that belongs to?
Well, that's a tricky question. So, for example, if it's a mammal, the best way to identify it is just to look at the teeth. If it's a chip of the bone, for example, like a teeny tiny, you can't even say what part of the body fossil was that. There is like no way to identify.
So if you were to find a piece of a tooth, how would you identify that? As one of the, or maybe maybe an Allosaurus or Tyrannosaurus or any kind of prehistoric creature?
First of all, we look at the formation. So what formation was that? What animals lived during that time? And we look at the size-wise. For example, Allosaurus, the Morrison formation, he was an apex predator. So we know if you see the tooth of a particular size of some theropod, most likely it is an Allosaur.
Yeah, for sure. With the climate being warmer, do you think animals are adapting to being more nocturnal or changing their behavior in hunting or feeding? Because I think that we obviously the climate is getting warmer. This might be this might be a debate for anyone. And for all the climate activists and climate people out there. What do you think? Are animals adapting to the change, or they're heading to another extinction?
Well, we are heading to the seventh mass extinction. There is, I think, no question. So we are in the process. If we are adapting to the nocturnal lifestyle, I don't think so, honestly. It will take some anatomical features and it will take millions of years. And I don't think we have this time.
So when we talk about, adapting to different environments or, feeding So, for example, an animal or a mammal that is always dependent, on daylight for hunting mammals, and because the climate is just too different, and they cannot adapt, they choose to hunt or feed during nighttime. Do you think? What's your opinion about that? Do you think it is very common now? And so I know, for example, lions, predators, they choose to hunt in the night. Where their prey is, they have less. Where it's easy for them, and they're most active during the night. Even tigers or any other cat we can look at. Has this changed? Or has this always been like that before?
I'm not specialized in mammals, so unfortunately I can't talk about the cats and especially the modern animals. So as far as I know, if you hunt at night, so your vision should be adapted to this lifestyle and this type of behavior. And of course, your prey should be active during the night hours as well.
Yeah, for sure.
Yeah, so I believe there are just too many changes, and it will take thousands of years to adapt to this anatomically and maybe less behaviorally.
Yeah. You said we are in that stage to that mass extinction. Can you tell us can you tell me a little bit about that?
So as far as we can see, a lot of species are extinct already, or on the blink of extinction, and the pace is much higher than we even predicted 5 years ago. So we are moving to a certain point of no return. The ice caps are melting, so the Greenland won't be icy anymore, which is exciting on one hand. As a paleontologist, I just want to really look what is there, but on the other hand, it will change the way our Earth, our planet looks. For example, the rise of the ocean will trigger a lot of animals that live near the shore to went extinct. And with this extinction, so the food web will change.
Yeah, for sure. Too bad. I mean, it sounds like it's not a good thing. But I don't know. It could either be something, that could benefit the environment. You never know.
I don't think it can benefit the environment. If all the food sources will disappear, it will trigger the whole food web to simply go extinct. I mean, if you don't have algae, if you don't have plant materials, plankton, and all of those, like herbivores won't survive, and the predators won't survive. So it triggers the whole chain to disappear.
Yeah. What would you do if you were not a paleontologist? What would be your other route?
Oh, I really love boating. Probably I will boat the planet, and I don't know, take photographs. I love photography as well. Or maybe I will just still be doing the project management. It's not so fun.
That's interesting. Yeah, I love boating too, but it's just that I haven't been in so many boats. Do you often go on boat rides?
Yeah, I try to do it every week.
Wow, that's nice. That's interesting. Why boating?
Sorry, say again.
Why did you choose boating?
It's very relaxing, I would say. I can just focus on driving and thinking. A lot of my posts are written, by the way, like in my mind when I'm just driving a boat. I'm just dictating and then just posting on social media. So it's a good thing because you are just closed in a small environment. There is just nothing between you and the sea. You can explore a lot of islands, remote islands, and explore the fossils there. Just a couple of days ago, I think it was last week, I was on very close to Canada. It's called a Sucia Island, and it's the only Cretaceous rocks in the Washington state. We found a theropod bone. I believe it was a leg bone there. So this is the only theropod from the Washington state. There are also beautiful ammonites and invertebrates.
Wow. And what island was that again? Sorry.
It's a small island in Friday Harbor. It's called the Susha Island.
Mm-hmm. Okay. That's interesting. Interesting how fossils are all around us, and we don't even know.
Everywhere.
Yeah, for sure. What's the biggest area about your role you're very curious about, and what are some of the things you're working on and researching about right now?
So I have a couple big projects. One of them, Museum Traveler, as probably you know. So this is a platform that will have all the museums as a virtual reality experience, plus all the videos that are made in partnership with the educators and the curators, directors of the museum. So it is an opportunity for everybody to just go and experience the science and the museums. And you don't need to go and fly and just be in person there.
Yeah, that's very awesome. I think that's a great idea of
Thank you.
What you're doing there. What was or is your favorite project in paleontology so far? Would you tell me could you share some of your current projects or?
Yeah, absolutely. So I'm working on a conservation project. I'm trying to do as many 3D photogrammetry projects of the tracks that are left in the field. So some sites, unfortunately, you just like can't excavate and move to the museums. There is no storage place, or sometimes it's just like super huge or remote. And yeah, I mean, not every fossil can be transported and stored under conditions which will save it for the future research and studies. So I'm trying to preserve the knowledge, at least as a digital fossil, or with photogrammetry, you can definitely preserve very accurately all the depths and all the paces and all the details of the track sites. Even if you don't know how to interpret it right now, you can save it and you can study it later.
Yeah,
and as I mentioned before, so unfortunately, tracks are eroding very fast.
Yeah, unfortunately, that is eroding very fast because of the age. I think you hit the nail right on the head. That the only way to study these things is through pictures, right? Taking pictures. And I was reading one of your articles where they've been doing this for so many years, and it just the best way to analyze or study these things is through photographs, or something called, or the term called photogrammetry. And I was reading this article about crocodilians, where you had posted about crocodilians. And did you find crocodiles in that area when you took pictures, or?
So it was a known site. It was discovered in 1930s, and then it was studied 11 years ago. So Martin Lockley published his paper on the site. So he studied the tracks and he put all the explanations. And by the way, when I was doing photogrammetry, Martin Lockley was at the site as well. What surprised me, nobody noticed how severe was the erosion. So I compared the results of my photogrammetry. I just measured the depth, and I compared it to the results of 10, 11 years old studies, the photos and the measurements in the Martin Lockley's paper. It went down from 12 millimeters in depth to 3 millimeters. So this is a huge erosion, I would say. So we lost a lot.
Yeah, for sure. When you're on site, when you're working out in the field, obviously you have a lot of computer technology with you. How do you sit down and analyze? Is it after your findings? Do you sit down and analyze what you have found, and you compare your pictures, and you come out with a date that this is how fast it is eroding. And you know what I mean? Because how do you know that this is eroding so fast?
That's a great question. So part of my conservation project is to compare the results with the previous photogrammetry. So for example, if the photogrammetry was done at that site, let's say 5 years ago, we can compare the level of depth.
Yeah.
And we can even predict, for example, what kind of lithology is more affected by erosion and elements.
So obviously there was someone else who did take pictures of that site before, and then you compared that with the current.
Yes, this is one part of my project as well, just to see how fast erosion and what type of lithology is the most affected.
Yeah, for sure. Where have you traveled for your career? Do you have a favorite destination when it comes to fossils, and why?
Oh, hard.
Well, you'll be traveling pretty soon because we
choose.
have a museum traveler coming up soon. But besides that,
I think I really love Utah. And most of people who are following and know me probably think that I live in Utah because I am doing a lot of studies there. I love the Moab area. There are a lot of pretty good track sites. Yeah, well, I mean, I'm biased. Yeah, but there was also a lot of body fossils. So the Morse information is home for Diplodocus and Allosaurus.
Yeah, that's interesting. And did you find all this in Utah?
Yes.
The track sites, correct? You said?
Yep.
Oh, wow.
There are a lot of track sites. Some of the track sites, I would say there's a migration pass of 20 miles. So probably herds of sauropods were traveling along.
Wow, that is amazing. And
That is amazing.
It is still preserved.
It is preserved, yes, but my fear is we can't remove all the elements. We can't put a tent or like any roof, so we can't just like preserve it from water and snow and wind. So it is eroding.
How far are the tracks? Like, do they keep going or?
So the longest side, as far as I know, is 20 miles.
Wow.
Which is unbelievable, right? There is a huge site. It's called the Mega Track Site, Trackways, and it goes pretty much to New Mexico.
From Utah?
Yes.
Wow. That is amazing. Like,
that is unbelievable. Yeah.
That's really interesting. So from Utah to Mexico, you said?
To New Mexico, yeah.
To New Mexico. Wow.
And Texas.
And Texas. So obviously we know there is record of mass migration during that time.
Yeah, so we can speculate that probably it was a seasonal migration.
For food, water.
Yeah, probably, or nesting.
Nesting. Yeah. Just like mammals today. I mean, there's always birds. Yeah, for sure. They do migrate for food, water, nesting, and I was watching this show on Netflix called it's David Attenborough's mass migration program, and it's one of the most important things that occur in Earth. Animals moving from one place to another, and obviously this also happened in the time of dinosaurs, when they're moving from one place to another place, and in search of food. And I think that's the same with what they have today going on. So it's a historic event that is repeating itself. That's very interesting. Now, who was the first paleontologist you met? And can you tell me how was the interaction? I'm just very curious to know.
I met a lot of paleontologists on social media, and most of my interactions were online. So I was asking a lot of questions. The first field work I had was with Dr. Paul Murphy. It was in September, 1 year ago. And starting from last September, I was doing field works pretty much every month.
kind of questions did you ask?
Everything that I can't get from the books. So the field experience, the practice. When you read something, you have an assumption in your head, but when you go to the field, it's like brand new brain, and you have nothing to compare with the pictures of the book. And sometimes you just learning everything from scratch.
Yeah.
So nothing can replace the field experience, I would say.
Yeah. Why do you think prehistoric animals are so important to us today?
Probably by learning the prehistoric animals, we can learn a lot about where we are going. For example, this summer we were working on an NSF grant project that studies the extinction that occurred pretty recently, just 55 million years ago. The results, I would say, just to compare the data, shows that the rate of the climate change and the temperature rise right now is much higher
than compared to before.
Yes, this is very concerning, I would say.
Wow.
Yeah, so we have to do the changes to stop that.
Do you think there are changes being made?
Oh, well, I hope so, but I don't see it.
Yeah.
I believe the changes should be done at the government level, because you can't push the corporations to stop the pollution if it's legal. So they will do everything that is legal. If the government will just push all the big factories to stop using certain types of chemicals, I hope it will help to slow down. I don't know if it's possible to reverse, but at least we need some time to just think about measures.
Yeah, we're obviously headed there. I feel bad just because we are using this for our own selfish needs here. Oceans, for example. There's always garbage thrown in the oceans. You can always see videos of animals being caught in plastic debris and a lot of stuff. And then there are people trying to rescue these animals. Turtles, for example. I saw this one video of this turtle got caught in a fishing net that was left in the ocean, or plastic that was just tied around its body. And obviously the industries, like you mentioned, are polluting the environment, which affects the animals. The rate of the rate of pollution has increased significantly over the years, especially now where we're going. And I was looking at some of the data presented on the internet about whales, about mammals like that, and whales are obviously declining in population because of that. Sharks, for example, are being hunted down for their fins and all that stuff. It's a big thing about climate. I was here in Canada. We have a place called I keep forgetting about this place, but it is in Saskatchewan. Where polar bears actually live, and it's not Saskatchewan. I think it's Churchill, Manitoba. It's way up north, and scientists, there's these polar bears migrate during the winter because the rate of ice that is disappearing is really very fast. So they have to keep moving outside of Churchill, Manitoba, which is really alarming. And I'm not sure how the polar bears are going to survive in the next few years, and who's looking into that. But let's hope something good happens about that. What's the most interesting dinosaur fossil you've ever found?
So for me, the most interesting probably were tracks. I found, which is, I assume, was a Dilophosaurus track, which did step on a plant material, and both did preserve. Okay. So this is a crushed seeds and plants, and a pretty nicely preserved Dilophosaurus track.
Yeah. Refresh my memory again. Dilophosaurus, what is it, a plant-eating or meat-eating?
No, Dilophosaurus was an apex predator during the early Jurassic. So probably you watched the Jurassic Park. Do you remember this double-crested creature, yes, pretty small, which like had a frill and speed venom, which is like nothing in reality. Yeah, but this is Dilophosaurus.
Where did you find the track?
In Arizona, and it was just like totally accidentally. Another nice track, probably of Dilophosaurus as well, I found in Utah. It's also late Triassic, early Jurassic.
Mm-hmm. Wow, that's interesting. So did you? What did you do when you found the track?
So the track in Utah is now at the Museum Moab Giants. So we were prospecting the formation under the permit with Martin Lockley, and everything can be collected and curated at the museum, of course.
Interesting. Can you tell me, I know we talked briefly about photogrammetry. Can you tell us, and can you tell me and the audience who don't know, a little bit about photogrammetry?
Oh, yeah, absolutely. So I take a lot of photos with a big overlaps. So I'm slowly moving from like 30 centimeters left, up and down. So I'm taking a lot of photos, and then I'm aligning all the dots and points in this specialized software to make a 3D model of that.
Okay. And you compare these photos together, and you make a 3D model through. How do you make the 3D model?
There are a lot of steps in the process, like 100 steps of instructions. So every photo you take, it has, depending on like my settings, for example, I'm using 100,000 points. So software on every single photograph recognizes 100,000 photos on every single photo.
Yeah.
And then it aligns to have the matching points. For example, this point on this photo is the same point on that photo. This is the process of aligning all the photographs together. Then I'm building the mesh.
Yeah.
Yes. On top of that, since I'm doing it with the camera has some physical qualities, and I have to go through the error corrections. Because the lenses, they have the curves, and what you take the photos, it's not really what you see and what is the real depths and the structures of the fossil track.
Yeah, for sure. Is this a most efficient way to?
This is the most efficient way. Yeah, there are a lot of ways how to do that. You can, for example, do it the old school way. You can have the plaster, and you can just pour and then dry and have the cast of the footprint. But so what is like, there are cons and pros. So to have the cast is you don't need to have the software and all the knowledge how to do photogrammetry properly. You don't need to worry about the camera calibration and error reductions and building all the mesh and all of that. But you can't reproduce the cast easily and spread it around the globe just to everybody. You have to take a look and compare the, for example, Dilophosaurus tracks on the east side or on the west side in Utah. So, I mean, with digitalizing, you can efficiently share and have analysis around the globe.
Yeah, that's an interesting way of, researching through casting, I believe. And how old is this technology that we are using right now?
It's very old.
Photogrammetry.
Surprisingly, it's probably for 70, 80 years already. So we have better cameras, we have better software. So we have a lot of practice and experience. So right now we can say about the best practices how to do photogrammetry.
Interesting.
Yeah.
And with the photos that we take, is there a team of people that you work with, or do you sit down by yourself and you analyze?
So that's a great question. I work with the team. For example, since you mentioned David Attenborough, I worked at the site he visited 30 years ago in Utah. It was near Moab. I was working there with Dr. Martin Lockley and Nora Novke. So they were studying the tracks and making the notes, and I was doing the photogrammetry for them.
Cool. And you work with these people, and you sit down with them later on to analyze what the age is, and how fast it is eroding, and all that.
The ages are already determined, but yes. So we are looking into the level of erosion. So we were comparing the results. Martin Lockley explored the site, I believe, 20 years ago and 30 years ago.
Wow. That's amazing. How do you know the age right away?
So we know the age of the formation, and we see that the formation goes, for example, so this is totally the same rocks as over there.
Oh.
There are a lot of ways how to determine the age if you don't know the formation, for example. So you can use the isotope, you can do the index fossils, for example. Index fossils, they are species that lived during very geologically short time. So, for example, if you see the fossil of this particular shell and you know that it was just from, for example, 150 million years to 152 million years, so you know exactly.
Yeah, that's amazing to even look at it that way with and determine how old the fossils are. And, for example, if you find a fossil, you determine right there and then that this is this much million years old. And it's very interesting. When you work with a team, how do you come up? How do you choose your team, or do you have a team that is already there with you?
So usually I work with specialist scientists who study track sites. So my pleasure is to do photogrammetry and complement their studies with my research.
That's very interesting. Do you always have those people when you're in the field?
Not always. So there are quite a lot of times when I'm just exploring by myself, and I'm prospecting and looking for new fossils or new track sites.
Very interesting. All right. Can you tell me some of the best places in the world to collect dinosaur fossils? What do you do with your findings?
So if you're talking about the dinosaur fossils in particular, probably Montana, South Dakota are really great places. The Hell Creek Formation, where all the Tyrannosauruses and Triceratops.
Oh, wow.
Yeah, but again, so you can't collect it legally unless you have a permit to do that.
Are there more Tyrannosaurus fossils out there?
Well, all vertebrate fossils are quite rare. So if comparing, for example, to invertebrates, vertebrate fossils are rare. Yeah. So I can't say that a lot of Tyrannosaurus rex, especially complete.
Yeah. I know
a lot of material.
Yeah, I know here in Alberta, there was there were a few prehistoric carnivores like the Albertosaurus and other species out here, just because of the landscape. I visited the museum in Saskatchewan. I think this was in Regina, and they said this Tyrannosaurus Rex, the head itself was huge, massive. But comparing to Sioux, this is not as complete as Sioux. And I think this was 70 to 80% complete. And they did come up with the name of this dinosaur called Stan. And 80% of this T-Rex is complete. And they found it here in Alberta, which is amazing. Have you, when you look at these prehistoric creatures like the Tyrannosaurus apex creatures, how hard is it to find these fossils? Is a location determined to
So it's quite rare to find a complete fossil. I think 5 or 6 years ago, a group of paleontologists and volunteers found the most complete Tyrannosaurus Rex skull, tough slough. And by the way, it's in Washington State right now. It's on display at the Burke Museum. It's, I believe, 99 or 98% complete. It was a juvenile Tyrannosaurus Rex.
So it is more complete than Sioux.
It's a skull.
Okay, just a skull.
It's not only the skull, but the skull is the most complete.
Wow. What, they couldn't find the rest of the body, or just the skull?
They found, but the skeleton is not complete, as for example the Sioux.
Oh yeah. And for the audience there, where did they find Sioux exactly?
I don't know the exact locality. I believe it was on a private land, so maybe we can ask Larson about that.
Yeah, no, for sure. I was watching one of the episodes, it's just amazing that they found something, that has been well preserved for so many years. Sioux, of course, is named after the paleontologist who found the Tyrannosaurus Rex. And I don't know, have you seen the life-size model after that?
I did. So I saw the replica, the cast of that at the Denver Museum of Nature and Science. It was enormous.
Is it really big?
It is huge.
Huge, okay. And that's the exact replica of Sioux?
Yep.
Oh, wow. And where is it again?
It was on display. It was a travel exhibit, so it was on display at the Denver Museum of Nature and Science. I believe it's already not on display, so it moved somewhere.
Yeah.
I hope to visit the Field Museum in Chicago. So yeah, it is an unbelievable specimen.
The Field Museum is where Sioux is located, correct?
Yeah.
Yeah. I believe Sioux was auctioned before it was sold to the museum in Chicago. I could be wrong, but I just read the facts.
Yes, it was auctioned. I believe one of the IT corporations, maybe I'm mistaken, I think Microsoft purchased the Sioux and then they just donated.
That's amazing. Yeah.
I think this is how all the fossils should be purchased.
Yeah, for sure. That's amazing. Can you tell me, why did dinosaurs become so large? And what was the main reason for that?
Again, the climate, the bioenvironment. So the level of the oxygen was much higher and the climate was also much warmer than today.
Mm-hmm.
So, for example, in Washington up to Canada, we had crocodiles and we have palm frond trees. So it's very different climate. And of course, the vegetation was abundant. There were a lot of food sources. It allowed herbivores to grow in sizes because simply there was so much food. And also to explore new niches like the treetops. And with the rise of herbivores, of course, the predators, the carnivores also increased in sizes.
So because the oxygen level was so much compared to what we have today, and these animals were massive, Is that also one of the reasons you mentioned?
Yeah, so the raise in oxygen, the oxygen level was higher and the climate was much warmer.
What happens when there's a surplus of oxygen? What happens to that, to the environment?
So you mean when we are raising the level of oxygen or decreasing?
Raising. Yeah, when there's, yeah.
I believe there are a couple of studies. So, for example, if the level of oxygen will raise right now, a lot of animals will have trouble breathing because we are not adapted to that. Probably new species of plants will evolve with a higher level of oxygens, and new species of herbivores and carnivores. But the current animals, they would be hardly adapted.
So with the current species here, do you think they will all die like that if the oxygen level was too high?
Oh yeah, absolutely.
And
people won't be able to breathe.
Yeah. And with the how is the oxygen level now compared to how it was before?
So there are some controversial studies. Most of the studies say that the level during the time of the dinosaurs were higher. A couple of months ago, I read a study that it was opposite, so it was lower.
So we don't know yet how the oxygen level was compared to present day.
As always, there are controversial studies and theories.
Yeah, no, for sure.
I personally think it was higher.
It was higher, yeah. Why? How did scientists discover that modern birds are actually dinosaurs? What evidence? What evidence do we have?
Oh, that's also a great question. One of my favorites. I just had the paleontology class for kids for the last 2 weeks, and we went outside and we saw a blue jay, and the blue jay lost a feather. So I just took it from the floor and like, guys, we have the dinosaur feather. And everybody was like, no way, birds are not dinosaurs. Yes, they are dinosaurs. They're not only descended, they are dinosaurs. So we think that all the birds belong to the theropod group of animals. It was obvious for decades. Why was it controversial? Because of two simple reasons. The first is feathers, and the second is this fused clavicle, the wishbone. So we have this fused clavicle furcula in birds, in modern birds, but we couldn't find that for a lot of years in theropods. Finally, we did. So another reason is feathers. Feathers were found like 100% for sure in 1993, I believe, in China. It was Sinorapteryx. So in China, fossils and theropods are preserved with soft tissues. For some, we can even see the color of the feathers. And I believe Professor Phil Curie traveled to China, and when he saw this Sinorapteryx for the first time, it was just, wow, this is the biggest discovery we've made in the 20th century.
Yeah, that's interesting. Because I always thought that the reptiles were very close to dinosaurs.
They are reptiles. Birds are reptiles too.
And then if you look at, because the way I've seen crocodiles, like crocodiles, I don't know how these guys survived, because obviously they adapted over the years, and I think modern day dinosaurs are very close to crocodiles. I don't know. I could be wrong, but birds
are close to
crocodiles. Yeah. And when you look at the anatomy of a crocodile and look at its jaws, and I would say that is as close to what we had as maybe a Tyrannosaurus could be. The jaw structure could be as close to a Tyrannosaurus Rex, but obviously I'm not sure. And then when you look at iguanas, and if you look at these monitor lizards, and they all look very similar to a dinosaur. What do you think? What are your views on that?
So we really don't know how they looked, right? So when we are comparing the dinosaurs in so let's make a step back, right? So they're all are archosaurs, the same family, and they evolved during the same period. So in the Middle Triassic, all the groups. We can compare, for example, our vision. If you're talking about the skin of the Tyrannosaurus Rex, so we can definitely compare it to the modern day birds. We can compare it to modern day reptiles, including crocodilians. But how they really looked, we have no idea.
Yeah. Which is my another question, which is the other question I had. Do you think, these dinosaurs, were they exactly, did they look the same as the skin color as we have today, like in crocodiles and iguanas? I know this is very hard for you to answer. We don't know, maybe.
I think it's hard to answer for everybody because the soft tissue, we don't know the color of the skin, of the scales.
What about Ankylosaurus? They did find one well-preserved Ankylosaurus.
Yes, Nodosaurus, yeah. In Canada, by the way.
Yeah, and it is very, very well preserved and very, I don't know where it is. Gosh, I'd love to see it. And, the round scales on it, it's almost like like a crocodile or something. It has round scales, more similar to reptiles that we see today. And I was, blown by that. But
so if we're talking about the Tyrannosaurus Rex, it was a theropod. So we might think about, like, if you had feathers for display, or sexual dimorphism, right? So when we're talking about Ankylosaurus, I don't think it was feathered.
Yeah, no, for sure. How many types of Tyrannosaurs are there? And was the ecology very different than what we have today?
So the whole family evolved in Asia and then moved their way to the North America. There are a lot of animals which are considered tyrannosaurids. Just recently, I got a couple. I did posts about Tyrannosaurus Rex, and I got a couple of questions. No way, there were more than one Tyrannosaurus Rex. Yeah, there were like Gorgosaurus, Albertosaurus. There were many different species. Like in Mongolia, we have Tarbosaurus. So there were quite a lot of different animals. But what is similar, one common trace, I would say, they all were apex predators.
Yeah. Was the ecology a little bit different than what we have today?
Oh yeah, it was quite different. Yeah, so it was much warmer. The Cretaceous, the late Cretaceous, I would say that there were less land mass than we have today. The paleo environment was warmer, more humid.
Yeah, that's interesting. So altogether, there is a whole group of different species in the Tyrannosaurus family. There's not one.
So we can name a couple genus. Yes, a lot of species.
Yeah. What about Gigantosaurus? Yes. Is that the same family?
No.
It's a different family.
Yeah.
Spinosaurus?
Yeah, we have Gorgosaurus in Tyrannosaurus family. Spinosaurus, it's quite different.
Yeah. Do you think Spinosaurus was mostly adapted to land or mostly close to the pond?
That is highly debated. So honestly, I read a couple of studies about the oxygen isotope in the bones and the comparison between, for example, the terrestrial animals and aquatic animals. So based on that study, it's more closely related to, I would say, like semi-aquatic animals.
So
but we don't know. So probably so we found the tail, which looked like a paddle, right? So scientists assume that this tail was used to dive and like propel itself.
I saw this video. They found one fossil of a Spinosaurus, and I think this was in Argentina. I could be wrong. There was one guy who is a paleontologist. He found this fossil in Argentina of a complete skeleton of a Spinosaurus, which is largely, and he told it that these animals were very, very closely, they hung out around ponds, rivers, and they were very aquatic. And but I don't. There is, as of now, there is no evidence that these animals were really aquatic or not. Is that correct?
Honestly, I have no idea about the Spinosaurus from South America. I read only the studies based on the finds in Africa. Yeah, so I will take a look.
Yeah, I don't know how they found this fossil. Finding this fossil was actually, they came up because they found this fossil, and then it was actually lost. And then they found some people, there was some people found the fossil again, and they came up with the whole skeleton of a Spinosaurus. And because this is much larger than what we can imagine, Spinosaurus.
Yeah, it was the biggest theropod. Yeah, it was enormous.
And then I don't know how they found this fossil. I don't know where we could see the fossil, but I should, maybe I should check out some of the websites and see where we could actually find Spinosaurus skeleton or something like that.
Yeah, unfortunately, I'm aware only about the studies and finds from Africa.
Yeah. Have you researched a lot about Tyrannosaurus, Allosaurus? Have you done any findings, or have you come across people who have done findings? And what was your experience?
I talk to paleontologists pretty much every day. So yeah, I meet a lot of scientists who are doing something different than track sites. Regarding Spinosaurus, I recently talked to Matthew Masbracker, so he shared his vision on these animals. Yeah,
for sure. Let's talk, Alena, let's talk about the timeline of the dinosaurs, the Triassic, the late Jurassic, and the Cretaceous and the late Cretaceous period. I think this is very important, but what exactly led to the mass extinction?
You mean in the late Cretaceous?
Yes, exactly.
Well, poor dinosaurs faced a couple extinction events. So
I'm going to, sorry. People say there was an asteroid.
If we are talking about the late Cretaceous, yes. So there was an asteroid. Yes, absolutely, no doubt. And it was a huge impact. And it definitely affected all the living organisms, including the dinosaurs, and all non-avian dinosaurs went extinct during this time. If we can speculate, I probably think that was a series of events. So it was severe and quite elongated in time volcanic activities. So probably it was affecting the climate and the carbon dioxide in the atmosphere, plus the asteroid just finished the process. Or of course, I don't know if we will ever find out if it's just like one single event, the asteroid, or it's a combination, but I believe this is just a series of events. Quite recently, there was a paper, quite interesting as well. I said interesting 3 times. So the paper revealed the numbers of dinosaur species were decreasing quite before the asteroid event. So what led to this decrease in numbers? Probably the climate change. So the plants were not so abundant, and there were not enough food sources for herbivores. We see decline in Triceratops and Hadrosaurs. So ceratopsians and hadrosaurs were decreasing in numbers dramatically, and of course the carnivorous dinosaurs as well. I think it was an unfortunate series of events.
I completely agree. I don't think for the people who are wanting to argue with me, they can. But I don't think it is one single event. It is a mass, chain of events that occurred for the extinction. And I don't think just the asteroid could have wiped out all the dinosaurs. Climate change, for sure, 100% could be one of the factors. Lack of food resources, the environment changing, for sure, could be also another event that it was very hard for these animals to find food, and thus they had to migrate from one place to another place to find food. And then, while they were migrating, some of them died because of the weather, and it was just climate being so harsh, and it just led to extinction of these animals. And it is obviously I'm very sure that it is a chain of events that occurred over a period of time. And then lastly, the asteroid. I'm not sure about the asteroid, but they do say there was an asteroid and there's a crater out somewhere in South America that
in North America, Mexico,
where they have that crater. But I'm not sure about that. But I think it is obviously a chain of events, and we could see the chain of events happening right now here, and we could see animals disappearing. For example, there are a few, and there are a lot of human efforts being made to save animals. So, for example, mammals like carnivore mammals like tigers. Tigers are. At one point, they were only Indian tigers in Asia were almost, their numbers were really low. And when I say low, it's more like vulnerable, closer to extinction. And thanks to the government, they realized, wow, we need to do something. And there's around 4,000 right now. We also see, like you mentioned, you saw tracks, you see track sites of these animals always migrating. Obviously, they're migrating for food or even something that they need, like nesting and all those sites. And some of them could have died of natural causes and climate, and this could have been a chain of events for sure.
Yeah, but asteroid definitely contributed to that. The nuclear winter and acid rains.
Yeah, for sure.
Yes, lack of food sources.
Yeah. What is your favorite prehistoric animal, and why is it different? Was it different when you were younger?
When I was young, my favorite probably was a Triceratops. I had a little 5 centimeters model of the Triceratops, and I was holding it almost everywhere, I was traveling with it. Yeah, so right now I can say that I love tracks.
Okay.
Yeah, so if I can choose a couple prehistoric animals, I would choose a Troodon. It's a really interesting theropod, quite intelligent. And so the dinosaurs' intelligence is another subject I'm really interested in. Tyrannosaurus rex, for sure. It's probably one of the most favorite dinosaurs, iconic dinosaurs of all. There are a lot of studies and we'll know a lot about it, same as the velociraptor.
Yeah. Is it true velociraptors were mostly in Asia, or were they seen here?
In Mongolia. Yeah, it was in Asia.
In Asia.
We don't have velociraptors fossils record here.
Yeah. I don't know why they still portray the velociraptor as a big 6 foot animal. I've seen, I was in Edmonton, Alberta, And I think if you ever get a chance, you should visit too.
I would love to.
And, Edmonton has a collection of these dinosaurs. And when I saw one of the fossils of Velociraptor, I was like, guys, you need to see what a Velociraptor looks like. It's not like how it is portrayed in the movies. The movies, do you think the movies, portrayed the Velociraptor correctly, or?
Oh, of course not.
Of course not.
It was just 1 meter tall and 2 meters in length. So in the movies, you mean the Jurassic Park?
Yeah, all the
right?
Jurassic Park movies. Yeah, for sure.
So no, this is not a Velociraptor.
The Velociraptor is known for its speed. It's known for its agility and hunting in packs. Do you think the Velociraptor?
Not really.
Not true? But in the movies, it is like that, right?
Yeah, in the movie. So probably it was a solitary predator which hunted during the night times. So we think that anatomically the eyes were adapted to nocturnal hunting for velociraptors. And if we are looking at the paleo environment, so I see this velociraptor as a tiger.
Oh, wow.
So it's, I think, taking all their food sources, climate, and all of this, probably it was a solitary predator rather than a pack hunter.
Interesting.
Deinonychus in North America. So we have a couple evidences of all the tracks of these theropods together. So it can lead to an assumption that probably they hunted the packs, but we can't say for sure. So we have a site with a group of animals of different ages together. It can also lead to an assumption that probably they were living or hunting together.
Yeah.
Yes, but for Velociraptor, I see it like a tiger.
Yeah, I was, I saw these, I saw this Velociraptor in the museum. I was like, this is what it looks like. In reality, I was pretty shocked, actually. So I was like, yeah, these guys fooled me pretty well. Also saw some good ones here. I can't wait to go to I've never been to the Royal Tyrrell Museum here in Alberta. I've never been there, although it's an hour away from me. I've never been there.
No
I'd like to. Yeah, it's very close to me. And also the Dinosaur Provincial Park, pretty close to where I am. You can find a lot of tracks and fossil bones there. I got so many chances, never got to visit. And yeah, it's interesting. And I think when I look back, I think when I look at the environment, because Alberta is pretty flat, and you can see when I envision Alberta, the landscape, I can for sure tell you, yeah, there was like, there were a group of animals here, like prehistoric animals like the Albertosaurus or any other. What's the vegetarian dinosaur? Pretty common dinosaur here that they found. Hadrosaurus, yeah, for example. They found a lot of those here. And have you ever visited the museums here, or have you been to Alberta?
Unfortunately, I have not. And so the Dinosaur Provincial Park is my dream locality, so I really want to visit.
Yeah, for sure. Is it possible? And I've always had this question in my mind. Maybe you can answer. Is it possible to clone dinosaurs with modern science and technology?
Well, so technologically, we are a little bit far from that. There are some studies that prove in 5-10 years we'll have a real dinosaur, or probably you heard about the Chickenosaurus project by Jack Horner. Yeah. They are working with...
I didn't hear about that. Could you tell me?
So they work with chicken embryos, and they are trying just to modify the genes and just push ahead the traces of the old non-avian dinosaurs ahead, which is technically is not a real dinosaur, but it's like a mutated version of a chicken.
When you say non-avian...
Non-avian, yeah, so it's like dinosaurs that wiped 66 million years ago.
So this was before?
Before the asteroid.
Okay. Are they working on that right now?
Yes, they do.
Wow, that's interesting. And why do they want to do that? Why do they want to raise something?
I think scientists always try an experiment. So I'm joking that we have 5 movies to prove it a bad idea.
Yeah, for sure. My next question is probably interesting to you. There's some really good dinosaur movies out there, like Land Before Time, Jurassic Park series, Walking with Dinosaurs, and King Kong. Did you have any favorite shows or movies that fueled your passion in paleontology or
I was
something like that?
definitely watching all of those. The Land Before Time was one of my favorites. The Jurassic Parks and World, yeah. I'm really, really waiting for the next Jurassic World. I think it will be epic.
Yeah. Do you have a favorite dinosaur in that movie?
All of them.
Yeah, that's what I thought. Yeah, they all look very nice.
Mm-hmm.
What is your favorite museum, Alena, and why?
Oh my gosh.
Or where is, should I rephrase that? Where is your favorite museum and why?
So one of my favorite museums is Morrison Museum of Natural History. It's in Colorado, in Morrison. What I love about this museum, it's not a big one, but you can touch and just rotate and probably like explore every single exhibit and display, which is very unusual, I would say. Also, there is always a tour guide who can answer all the questions.
Wow.
And there is always a group of people just roaming around, and they're curious about the Ice Age, the Cretaceous, and the Jurassic of the Colorado area.
Sorry, and where is this located?
So the Morrison is 30 minutes from Denver.
Mm-hmm.
And it's very close to also the Dinosaur Ridge, which is a absolutely wonderful and interesting, amazing place with tons of track sites on a wall, so you could just explore.
Yeah, that'd be amazing to see those track sites on a wall. It's pretty impressive.
Yeah, they are colored, so all the track sites are visibly just like they are colored in black.
Are those real track sites or just
yes, they are. They're real.
Wow, that's interesting. How accurate are the dinosaurs in the Jurassic Park movies we see?
Yeah, so we just discussed the Velociraptor. That was definitely not a Velociraptor. I believe they just decided to pick this name because it's more appealing. Also, Dilophosaurus. In reality, it was much taller. We have no idea about the frill, so it was totally made up. The same, the venom. So we don't have any signs, any fossil record that this dinosaurs had any signs of traces of venom.
Yeah. What do you think of the Tyrannosaurus? How accurate is that?
So we can speculate about the speed. We can speculate about the voice. Probably that was definitely not how it sounded. It was more like roaring on the low. I don't know. Everything is speculations. So we have the skeleton, we have the posture, we have an understanding how this animal like looked inside, but we have no idea about the skin, the feathers, the voice, or the speed. So there are a bunch of studies that are telling it was fast runners, and tons of studies it was like you can just like outrun the Tyrannosaurus Rex.
Which was actually my next question. I know there's a lot of speculation about this, and you probably must have talked about this on one of your posts. You did mention about I'm not sure, but you talked about did the Tyrannosaurus Rex have feathers, which is very speculative, and you must have got so many questions about this.
Oh, I did.
Can you explain, or can you tell me a little bit about that?
So first of all, we have a couple of skin specimens from the Hell Creek Formation. So we can say that on these specimens, we don't have any signs of feathers. Also looking at another Tyrannosaurid, like Tarbosaurus or Gargasaurus, we don't have any signs of feathers. Does it mean that it was completely scaly, no feathers? No. First of all, different types of, for example, scales and feathers can coexist. And not all formations produce soft tissues. So even if feathers were there, they simply just didn't fossilize. So we don't know.
Okay, that's a good analogy. So we don't know if these animals were feathered in a nutshell. Do you think they ran as fast as 40 kilometers per hour?
40 kilometers, I doubt. I like the study. There are so many, 5, 15, 25, 40, like you never know.
That's for something as huge as a T-Rex, as 40 kilometers. That's pretty fast.
It is. It is very fast.
Were they scavengers, do you think, or were they natural hunters?
I think they were opportunistic hunters.
Like bears.
Like bears, yes. No, bears are omnivores, so I don't think dinosaurs, yeah. But yeah, I believe they were hunters and they were scavengers and all in between.
That's very interesting. I didn't know that.
With a huge body mass, and there are some signs that probably they were hunting in packs. We don't know that, yes, but there are some studies that show that probably they were grouping together.
Yeah. Have they found evidence that the Tyrannosaurus is actually the vocalization of a Tyrannosaurus? Tyrannosaurus is pretty different than what we have seen in the movies.
We can speculate about that. So I really love the display at the Field Museum and the traveling exhibits at Denver. So you can just push the button and hear the roar of the T-Rex. Really? Yeah, so it was rumbling, low frequency. So this is how we think it probably sounded.
Yeah, more like an alligator or crocodile? Is that how close?
Not really.
Oh, I've never heard of it, but I'd love to hear about the vocalization of a Tyrannosaurus. And in terms of the behavior, were they mostly very, now they had to raise their young, obviously they had to breed, and they had to look for food constantly because food supply obviously could have been one of the challenge for them. Do you think they also migrated from one place to another place in search of food? Or, when we see natural predators these days, we see, they're always, they have their own territory. They defend their territory, and they always are opportunists, right? They look for food like lions. Mm-hmm. Do you think that was the same case for the T-Rex?
We have no evidence, fossil records for the migration of the Tyrannosaurus rex. We have a lot of footprints, but there is no migration pattern, we can say. What is interesting, we have signs of brooding nesting behavior. So
of the Tyrannosaurus.
Mm-hmm. Yeah, so there were scratchers. The modern birds do that. So they're just scratching the ground when they build a nest or trying to attract a mate. Yeah. So we have the signs for Tyrannosaurus rex. I believe, unbelievable.
Do we have tracks of Tyrannosaurus?
Oh, yeah.
Yeah. What about nesting sites? Have we found eggs?
I don't know exactly about the eggs, but we have the nesting sites. Yes. So, like I said, we have this scratching. So we have a couple of Tyrannosaurus rex footprints nearby, and these scratching patterns, which we can interpret only like this mating, brooding, nesting behavior.
What was the nesting site like? How was the area?
It was in Colorado.
Yeah. Do you think the nesting site was very how would you describe the area as?
So that particular area, it was close to the dinosaur ridge. So it was a shallow. Maybe that is the reason why this science tracks preserved.
Was it very close to a pond? Was it close to a lake? More forested area, or?
It was very close to Western Sea.
Okay.
Yeah, so which ran from Canada to United States during the late Cretaceous. So it was a shore based on the ripple marks we see next to those scratch marks.
Yeah. Interesting. So, in terms of we have evidence that I think the most accurate would be Sue, which where she is right now in Chicago, I believe. We have evidence that these animals were huge, massive, and they were bipedal, and they had short arms, really short arms. I'm just curious, what did they use? What was the main primary purpose of those arms, right? Those really small, puny arms.
Yeah, so one of the theories is mating. So probably the male was holding a female.
Yeah.
This is probably the most accurate interpretation.
Yeah. And I've seen your post about, no, do you think they were the lip, were they lipped or were they without lips?
I think the truth is somewhere in between. So I don't think that the whole teeth were covered in lips.
Were their teeth outside? Outside the lips?
I think it was like half covered. A lot of modern reptiles do have this kind of coverage, the skin.
Like crocodiles? Like crocodiles? Okay. So you could actually see their teeth out. Wow.
Yep.
That was a really mean creature. It really looked so mean, for sure.
Absolutely.
Yeah, and you said you saw a skull, the Tyrannosaurus Rex, in one of the museums.
At the Berg we have the most complete Tyrannosaurus Rex skull. It is 18 years old juvenile.
18 years old juvenile. And how long do they live?
We think about 30 years.
So 18-year-old, okay. And what did you find out about that juvenile? What else did you find about?
I didn't study or read a lot of papers about this particular specimen. I was just watching it being prepped for a couple of years because I'm local, so I was visiting this museum a lot. What I really love about it is you can definitely see all the vessels of the Tyrannosaurus Rex.
Yeah.
You can see like how the muscles were attached. You can see the fused jaws, like how massive and powerful was the bite jaw force.
Yeah, and that's only 18 years old. Gosh. And yeah, so what when they obviously the juveniles, I think what happened was they were like birds. For example, the birds raise their young, and then when we look at birds like the golden eagle or any sort of eagle, they're also they're very close to dinosaurs as well, and they raise their young and they teach it how to fly, and they leave them. Was that the same case for dinosaurs? For the Tyrannosaurus or any other dinosaur, that they fed their young, and once they grew up to be a certain age, they would leave them, or something like that. Or they would.
We have some evidence. We have fossil records for particular groups. So, for example, we have some dinosaurs like Maiasaura. It was a huge nesting site, and there were specimens of different ages together. Probably we can assume that they were living together. Probably they were raising their young as a group, like a huge parental group. For some dinosaurs, we have evidences, for example, So we have a skeleton of an adult and a skeletons of juveniles and small ones, hatchlings. So there are different ages on one locality, which tells that probably they lived or traveled together.
Was that the same case for Diplodocus and Brontosaurus? Brontosaurus, or?
That's a good question. So probably, I personally have no idea, but probably not.
Yeah. Do you think they
I
had?
can't imagine these massive animals traveling along with I think hatchlings wouldn't survive without the adults. So probably it was their survival strategy just to follow the herd.
But how would they? Yeah, they would survive without the parents, and how would they feed themselves? That's another.
Mm-hmm.
I just don't know, but for sure, because these animals were large, right? Really large. I don't know how they.
In comparison, so it's like a couple levels building, and so the Apatosaurus was probably 1 meter tall. So in comparison to a huge building, I don't know how good were mothers, were they taking care of their babies, were they just noticing their babies were there? I don't know.
Yeah. Do you think it was the same as in, because we have birds these days, it's survival of the fittest. They get rid of the ones that they're not, can survive. I'm not sure with all of the birds, but do you think that was the same for dinosaurs?
Absolutely, I think so. Yeah, we have a lot of signs that the life in Mesozoic era was pretty harsh. Almost all the bones, for example, the Tyrannosaurus rex, we have all the injuries. I even have the track site, which shows the leaping behavior of the Allosaurus. So it was severely injured and it was just moving. Probably it was his last breath.
Yeah, for sure. Now, what suggestions do you have for our audience or someone who would like to be a paleontologist?
Read a lot of books. This is number one. So read as much and as possible. Also contact the local museum or local university with the paleontology or geological departments. Make contacts. A lot of paleontologists need help to process data or help during the field work, and just be number one to raise their hands and help with as much as possible.
Yeah.
Volunteering also is very important.
All right. Yeah. Do you plan on speaking on any events that may have been offered to you, or if so, could you share the details?
Yes. So my next will be on September 14th. I will be talking about the photogrammetry and my photogrammetry projects. We're showing some examples and presentations. It will be for Paleontological Society in Arizona.
And could you share the time with everyone?
7 p.m. Arizona time.
Arizona time. Okay.
Yeah, I can send you the details.
Yeah, for sure. And for people who'd like to know more, please do look into that, because you don't want to miss that for sure. And finally, for the listeners, how can anyone reach out to you, or do you have any social media handles you'd like to share?
Yes, I do have my pretty active Instagram. It's Alena Iskanderova. I can send you the handle, or probably you know that for sure. I have my paleontology blogs. It's paleontology.rocks. So the new project, the startups, is the Museum Traveler, and you can reach out through all these three.
Yeah. What is next for you, Alena? What do you plan to do in the next few years?
In the next few years, I hope that the museum travel will go good. COVID have put some restrictions and issues for the international travel, but we hope to enroll as many local United States museums as possible, and hopefully we'll get to the Canada. It's very close, and I really want to visit Alberta. So hopefully for the next couple years, we will be pretty busy filming and doing the virtual museums.
Yeah, it sounds exciting. with Museum Traveler especially. I'm excited to see what you guys put out there for the audience, and I'm sure you guys will do awesome. Well, I can't thank you enough for your time, Alena, and it was
thank you, David.
it was very exciting to talk to you, and I hope I get you again on the show. I'm sure there's so many other questions our listeners have, and they would like to know about you, and I would like to know more about your findings, your research more in depth, so we could connect again maybe in the future. Thanks for coming again, and I wish you all the very best for your work. And yeah, thank you. It was an honor to have you in the show.
Oh, thank you so much, David. It was a huge pleasure.
Thank you. Have a great weekend.
Thank you, you too.